For Book 1, Proposition 35, it states, parallelograms which are on the same base and in the same parallels are equal to one another. So, I have already drawn out our shape, and our givens are parallelogram ABCD, EBCF with the base of BC. We can see that at the bottom. And we know that AF and BC are parallel. And basically, we are trying to prove that ABCD, and EBCF are equal to each other. EBCF. So we're trying to prove that those two parallelograms are equal to one another. So for our step 1, we're going to say AD and CB are equal to each other because of Proposition 34 that states sides plus angles will be equal to each other, and it's basically the area of a parallelogram. So AD equals BC. Because of Proposition 34. So for step 2, we're going to say EF, and BC are equal to each other. And this is also because of Proposition 34, the area of a parallelogram, that the sides and angles will be equal to each other. So for step 3, now we're going to say that AD equals EF because of common notion 1, those which are equal to each other are also equal. And since we proved these two are equal and these two are equal, we can now say that these two are equal. So AD equals EF. Okay. So for our 4th step, we're going to say DE plus AD equals EF plus DE. So this plus this equals this plus that. And that is because of common notion 2, which is if equals are added to equal, which in this case we're adding DE, then the sum will be equal. So we're going to say DE plus AD equals EF plus DE. Okay, and for our 5th step, we're going to say that AE is equal to DF. And this is because of common notion 2 and common notion 4. And common notion 4 says those things which coincide with each other will also be equal. And I already explained common notion 2 is that we're adding things together. And so for 5, it was both of them. Common notion 2 and common notion 4. So for step 6, we're going to say AB equals DC. So this equals this. And this is going to be because of Proposition 34 again. And for step 7, we're going to start working with angles. So we're going to say FDC. So this angle here is equal to EAB, this angle here. And that is because of Proposition 29, which says the sum of interior angles will equal a right angle when added together. And so FDC equals E, A, B. Prop 23. And for step 8, we're going to say triangle EAB is equal to triangle FDC. And so EAB, FDC triangles this time. And that is because of proposition 4, which is our side angle side proposition. So we have so FDC equals triangle AEB. Okay, and for step 9, we're going to say that triangle EAB minus DGE is equal to FDC minus DGE. And this is because of combination 3, because angles which are subtracted, equals which are subtracted from equals will be equal. So we're basically taking this triangle, subtracting this triangle, and then taking this triangle, subtracting that triangle. So EAB minus DGE equals triangle FDC minus Okay, so now, before we move any further, I'm going to kind of pull out some shapes so that we can kind of see it better. So I'm going to pull out ABE and DCF. So we're going to take this, ABE, and so we have AEB and then DCF. And so basically we're pulling the shapes apart, and now we're going to pull out the shapes minus this little triangle here that we subtracted just a moment ago. So now we have AD, B, G. ABCG is going to be equal to EGCF. And this is because we subtracted DGE, this little triangle, and so these two are equal to each other. They're just our shapes subtracted from step 9 that we just did. And so we can also, I'm going to pull out one more shape after, well, we can pull it out now. So we're going to have, here, I'll do it right here. We're going to have AD and BC, and then we're also going to have our line G. And so AD, BC is equal to EF, BC. But we're also going to have our line G going through, and on this side, G as well. So these are all our shapes pulled out. We have the original subtracting and then kind of adding it back on. So now for step 10, we're going to say ABGD, this shape is going to be equal to this shape that we already pulled out. And so these two are equal. And this is because of common notion 3, which is we subtracted the triangle up there from our original shapes. And so now for 11, we are going to put these shapes, but we're going to add back G, C, B. So we're going to add, let me grab them. We're adding this one right here back to it. Or we didn't subtract it yet. So we're going to have our parallelograms that we just put equal, but now we're going to be adding on to them. So A, B, G, D plus our B, G, C equals G, F, B, C plus B, G. And this is because of common notion 2, which equals added to equals will also be equal. So in this case, we added GBC. So this was our final step that we're doing anything with. And step 11 is, or step 12 is our proof. We have ABCD equals EBCF. And this is a QED. And our answer, what we sought to prove, is down there. So that is the end of book 1, proposition 35.